Okay, so some of you guys were having difficulty with the continuity, and so I figured I would go over um, the three types of discontinuity. Um, so there are three types of discontinuity, but continuity is basically saying if you could draw it, right, without picking up your pen, that's continuous. It can be like this, it can be sharp, that's fine. This is still continuous, okay? This is not a function, obviously. Continuous is something you could draw without having to pick up your pen. But if we talk about the three types of discontinuities, the first we'll talk about is an infinite discontinuity, and this is an asymptote. This is something you've seen, of course. An asymptote is something you work with in pre-calc quite a bit. So if we were looking at this graphically, we could say, I don't know, we'll just draw this curve right here. Okay. And then we got a dotted line here, right? And we'll make this x equal to 3. So this graph might look like, let's see, I guess we'll say, I didn't draw a great graph here, but let's just say this is the graph f of x is equal to 1 over x minus 3. Okay? Well, when you examine the graph, you look at the top, and the top looks fine. This is fine. But you notice that there's an issue, a 0 in the bottom, and that's an issue. This is no good. So this is a vertical asymptote. X cannot equal 3, of course. So as you put in smaller and smaller numbers, right? You put in, let's say you put in 2.9, and you subtracted 3, so it's 1 over 2.9 minus 3. Well, that's going to be 1 over negative 0.1, so that's going to be negative 10. And that's going to eventually, it's going to keep getting higher and higher as you put in like 2.999, and that'll be like a negative really high number. So it's going to go to negative infinity as you go this way. You put in 2.9, you put in 2.99, 2.9999, okay? Oops. And if you're looking at the other side, okay, it's going to get really big as you put in 3.1, 3.001, 3.00001, and the limit doesn't exist here. The limit here is negative infinity, the limit here is positive infinity, but the limit as x approaches 3 doesn't exist. So this is the first type of discontinuity. Now, the next type of discontinuity is called a point or removable discontinuity. So point. So we looked at that. We talked about the numbers here in blue. We talked about what the algebra looks like, the function itself, and then we talked about the graph. That's an important thing to understand. This is point or removable. Okay. Spelling's probably not the greatest here. Let me give you an example. We'll start with an example. Let's say I gave you f of x equals, let me try to pick something similar to what I gave you. Okay, here's a pretty good one. I'm just going to make it x minus 1 in the bottom. So it's going to be x squared minus 1, and then x minus 1 in the bottom. So if we look at this, we note that what can x not equal? 1, right? So you know that x can't equal 1. But in this one case, we know that f of x is really equal to, well, x plus 1, x minus 1 over x minus 1, and this cancels. So f of x is really equal to x plus 1 if x is not equal to 1. Okay? If x equals to 1, then we have a big problem. We have 0 over 0. So what happens is this function is, this f of x right here, this function would be graphed exactly like this. The line where this is your b and this is your m right here. The slope-intercept line here, right? But what's happening at x equals 1? Well, at x equals 1, we have a hole in the graph. So right here, we'll say there's a hole in the graph. Okay, but this is pretty much f of x. Okay, so when it cancels out in top and bottom, you have a hole. Okay, trying to keep this as short as possible. So we're at 5.5 minutes. That's not bad. So when it cancels on top and bottom, you have a hole. No asymptote once it cancels out, and you can plug in and you're good. All right, so that's a removable discontinuity. Last type, jump discontinuity. Jump discontinuity. A jump discontinuity is basically only going to occur when we have a piecewise function or something like it. Hopefully you understand what a piecewise function is from your pre-calc as well. Let's look at a graph again. So we have a graph, and we want to say, let's say the following. Let's keep it simple here. G of x, we'll say g of x this time, is equal to, and now we're going to say, right, we're going to say x squared plus 1 if x is greater than 2. All right, and then we'll say negative x plus 3 if x is less than or equal to 2. Okay, let's get an idea of what's happening here. So any x that's 2 or greater, we're going to have basically this parabola. So why don't we just draw that parabola, this right here. It's pretty much this, right? Okay. But we know that it's really not, we're not using it for any of these negative values, right? We're only looking at when x is greater than 2. So we'll say right here, this is 2. And that's pretty much where that part of the piecewise function ends. So we have a gap here. Okay. Now, the other thing that we have to graph, g of x still, is going to be, we're going to go up to 3 here. 1, 2, 3, we'll say. That looks okay. And we're going to have a slope of negative 1, so we're going to have this line, right? But it stops right here. Okay. And we know that when x is 2, right? When x is 2, g of 2, right? G of this function, we're going to put it here, is going to be negative 2 plus 3. It's going to be 1. So this is the point 2, 1, we can say. What would this point be here? If we're looking at the parabola, if x was 2, in fact, right? Well, that would be 2 squared plus 1. This hole here that's not actually on the graph is 2, 5. Okay. So now as you're looking at this graph, right, and you're saying, is there a jump here? And you can see why this relates to limits, because remember that first worksheet I gave you is exactly like this. It was exactly like this. So this is how it connects to limits in a little while. We'll get to that. But right now you can see that, okay, I'm going along, and I'm drawing my line, and now I have a jump here. I literally would have to jump from one to the other. This is a hole, pretty obvious, and this is an asymptote, which is something you covered in detail. So those are your 3 types of discontinuity. This is a jump discontinuity. Had these matched up perfectly, the blue and the green, you actually wouldn't have a discontinuous function at all. You would have a continuous function if they matched. But because you have to jump, you cannot draw it without picking up your pen. You have to pick up your pen to draw it. That's a discontinuity, and this is a jump discontinuity. So jump generally is a piecewise function. That's what it looks like algebraically. You can put in numbers and see that this is what it's going to look like. We looked at the hole, right? Any other number other than x equals 1 is fine. It's just this line. But we have to note that if we're saying f of x equals x plus 1, we have to know that x cannot equal 1. And there's nothing there. It's undefined at that point. And then, of course, asymptote shouldn't be too big of a deal. X can't equal 3. So that's an infinite discontinuity. So that's continuity in a nutshell. If that helped a lot, let me know. If you're still very much lost, let me know. Otherwise, I'll assume you're doing okay. You're somewhere in the middle. Okay, well, we'll be in touch. And good work so far. You guys have done a really good job. I'll talk to you guys soon.